Did you get my message about reading the pages before class, my little announcement? When I send an announcement out, it just signals you that there's an announcement out there? That is so cool that it tells you, oh, he just announced something. On page 529, do you have paper to write notes on?
Yeah, I have it.
Everybody have some? You need some?
No, I have some.
Okay, because you're going to need them. In problems 1 and 2, you're supposed to sketch a broken line path as described. Do you know what a broken line path is? I remember reading about it, but I read all this stuff and it just ran it all through my head, and there's no way I have it down. So turn back to page 518 and write in your notes a definition of a broken line path. And then you can keep those notes and use them when it comes time for the exam over chapter 8. And what's a broken line path? You don't want to tell me.
It's a line that can be drawn without taking your pencil off the paper.
Is that a broken line path?
Yeah.
No.
No.
It's a curve.
That's a curve. Broken line path. Here's a line, break. 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 Here's a line, break.
Oh, like these.
And in this case, I had it come back and end where it started, so that means it's closed. If I would have stopped right there, it would have been open. Technicalities. So what's the second problem we're working? Both a simple and a closed one. What's simple? Oh, I could have drawn, let me draw another broken line one here. Broken, 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 broken. See that? Simple means it doesn't cross itself. Closed means it ends where it starts. I mean, I could do this. I could go, and it ends where it starts, but that's not what? Simple. Because simple does not cross itself. So let's draw one that's simple and closed. There you go. Right there. That's neither simple nor closed. So it's not simple, so that means it crosses itself. You see that? And it's not closed, so I don't go from here back to there. I mean, there's a lot of different ways you could draw it, but that's the idea. You're keeping those definitions in mind. And you'll need that in your notes, won't you, when it comes time to take the test and they ask questions about these things. In problems 3 through 7, use the alphabet that's listed there on page 529. State which letters form a path or a curve that is closed but not simple. Closed. What's closed mean? It ends where it starts. So go across the alphabet and let's pick out the ones that end where they start. D. See that? Then what's another one that ends where it starts? O.
Dr. Bonine, curves be simple or closed or whatever too? Does that apply to curves as well?
Let's see. A path or a curve. for number 4, they said a path or a curve. So it can be a path or a curve.
Mm.
So closed, I'm getting all the closed ones. Oh, is that it? That's all the closed ones? Now, which one is closed but not simple? What's simple mean?
It doesn't cross itself.
So, which one would be? Oh, I missed one. I went to D. See that one? I didn't think about it. Because I'm not used to making them with just one continuous line. So this alphabet thing, your past will affect the way, because you see the way I drew that one? I went, what did I do? Go doom, 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 or start down here and go doom, doom, doom. So this one's simple, this one's simple, this one's not simple. 4B, simple, but not closed. What does simple mean? It doesn't cross itself, but it's not closed. So that would be C. It doesn't cross itself and it's not closed. I, it doesn't cross itself, it's not closed. J, it doesn't cross itself and it's not closed. See what's going on? Okay. Number 6. If you take M, let's put M up here. Watch how I'm going to write it. And then connect the bottom. Will this polygon be concave or convex? What's the difference between concave and convex? Page 519. What's the difference between concave and convex?
Concave goes in on itself and convex goes outside.
That means I can take another marker, a different color, and I can connect points. Like I can connect this point and this point. You see that? With a line. And does it go outside the figure? What is that all about? There. Does that not work? You see that? If I can connect 2 points on the perimeter, on the edges, and it goes outside the figure, then that makes it what? Concave. Like it caves in on itself. Whereas if it, let me draw another one up here. Well, like a triangle or a rectangle. Okay, you start drawing lines to connect points on here. And you see that? No matter where you draw the lines, they all stay within. It keeps them in the cave. Or it does, it's that's convex, isn't it? No line segments, joining points will ever go outside the polygon. So that one's convex. Number 8. Look at the traffic signs on page 529. Make that number very clear. 529.
28.
And name the shape of the information sign. No, not 529. 520. 520. Just 520. Fix that color. 520. The information sign, what shape is that? Those little black circles at the bottom of page 520? Little black shapes. What shape is an information sign?
A rectangle.
Thank you. What shape is the no passing sign?
Triangle.
Thank you. Problems 9 through 16. Name each quadrilateral. So what is 10?
Is it a parallelogram?
522. What is number 10?
Oh, number 10.
Problem number 10?
Is it a parallelogram?
Yes, it is. What's number 12?
Square.
Now, isn't it also a parallelogram?
It's also quadrilateral.
But it's a more particular, so they would want you to say square for that one, because it's got that right angle in it. When you see those right angles in parallelograms, they want you to call them something special. Number
How
14,
do you spell parallel?
look at those pictures on page 522. What's number 14?
Trapezoid,
Yep. What's number 16?
parallelogram.
Do those
Oh, just kidding.
do those sides all look parallel? The top and the bottom are for 16, but what about the other two? So they're not parallel, so what would that make it?
They're also trapezoid.
There you go. But you see what's happened? That this trapezoid, see, this is how they mess with your head. This one, number 16, is like turned upside down, isn't it? And sometimes you just have to take things and turn them back over to help fit in your mind, or just get practice learning to look at them right side up, upside down. Actually, number 14 looks like it's upside down too. I just, in my mind, is accustomed to seeing the longest line on the bottom. Number 18, 17 to 24. Classify each triangle as scalene, isosceles, or equilateral, and as acute, right, or obtuse. Do you remember all those words from geometry? No, they're on page 521. So what's number 18? Back on page 521. See why it helps if you read this stuff before? It just kind of keeps it from all running together. 521 says what scalene, isosceles, equilateral, acute, right, and obtuse mean. So what does that make 18?
It's a right triangle.
It's a right triangle.
It's isosceles right triangle. 18
Oh.
is.
Technical, good for you. It's a right triangle, but it's an isosceles right triangle. What about number 20? What is it?
Isosceles of two.
It's an isosceles acute triangle.
Really? How?
Which one is it?
20?
No, it's not acute. It's what?
Up to.
Obtuse.
It's like, wait,
Obtuse. And how do you know it's obtuse?
Is there some obtuse angle?
Because one of its angles is larger than 90 degrees. You go, that's kind of hard to tell. Okay, so get your little, did I give you a little index card the other day? Pull your little index card out and lay it up next to the top and say, yep, can you see that top angle for number 20 is bigger than 90 degrees? If you can't see it, then let me give you a little index card here from somewhere. Yeah, I got some of these things in here. Thought I did anyway. Where did I put it? Here we go. No, that's not it. Somewhere. And where did they go? Where did they go? Oh, I don't know why I'm not finding any.
You gave them all away to us
Is that what happened?
last year. Yeah.
Man, should have some more of those. Now I'll try to get some. Just take the corner of a piece of paper. That'll work. The corner of one of these pieces of paper. If you had trouble checking to see if something's a right angle, just lay that on it and you'll be able to see real quick what's going on. Number 22. What is it called? With that right angle, you know it's called a right triangle, but what kind of right triangle is it? It's a 3, 4, 5. Well, if none of the sides are the same length, what does that make it?
A cube.
What?
A cube?
Scaling.
I didn't hear you. I just didn't hear you say it out loud.
No, I said a cube, but I think it was scaling.
That's right.
Is it right?
That's
I
right.
was
Scalene
getting it
means
right.
the sides aren't the same length. So you're right, it's scalene. What's 24?
Isosceles, right?
It's got that right triangle thing in the corner, so and it's also 9 and 9, so that makes it isosceles. Isosceles. Aren't those funny words? Page 530. Whoops, page 530, exercise 26. The marked angles in the following triangles are all equal. Which, if any of the triangles, are similar? You know what makes triangles similar? It's on page 523. So here they are. Whoops. Erase this. Put these things up here. What are they? Where'd they go? 5 and 6. And what's the next one? 3 and 1.7. And now I'm going to turn this one around, okay? So it's easier to compare them. Put the right angle there, and that means this angle has a little mark in it. And that means this is 4, and this is 4.8. So are these three triangles similar? Which one is obviously not similar?
The middle one.
The one in the middle, because it doesn't have a right angle in it. And see, these have these two angles, so that means the third one's going to be the same too. So now the question is, are they similar? And what's the definition of similar? The corresponding sides are proportional. Watch what that means. Let's take this one out because we know it doesn't work. 6 over 4.8 equals 5 over 4. Is that true? What's 4 times 6? 24. What's 5 times 4.8? Got your calculator? 4.8 times 5 is 24. Well, look at that. When you cross multiply, if those two numbers match, that means this fraction equals this fraction. That means these two triangles are similar. So, what are you going to have to do to work number 25? Are those three triangles similar? This is one of your assignments, so I'll help you with it. Are those three triangles similar? Let's just pick two of them and check two of them out first. Let's take which two do you want to use? The first,
A and
second,
C.
third. Which ones?
A and
A and
C.
C.
A and what? A and
C.
C? Okay, so A is 4, 2, and 3. Oops. Okay, 4, 2, and 3. And what's C? 4/3?
Oh,
4/3? 2/3? And what? 1. Is that what it says?
A and C are similar?
I'm working yours, number 25.
Yeah.
Okay, is that what it says? Now, if they're similar, then I would say 4 over 4/3 has to equal 3 over 1. Do you follow me?
Yeah.
And 4 over 4/3 has to equal 2 over 2/3. You have to check all the sides out to see if they're proportional. So, let me change colors here. Let's use green. What's 4 times 1?
4.
4. So, what's 3 times 4/3?
4.
4. So it's okay here. Let's check this one out. What's 4 times 2/3? 8/3, right? What's 4/3 times 2? 8/3. So what do you conclude? Say, I still don't think they're similar. Then let's just go check out what's 2 over 2/3 times equals 3 over 1. You do them all, and what do you conclude? Yeah, they're similar, aren't they? Number 28. The following parallelograms are similar. What does that mean when it says they're similar?
They're the same, but not the same size.
And it means the corresponding sides are proportional. You got that? So for number 28, that means I have these. Oh, they want me to find. Okay, I've got this. Don't use green anymore. That's not dark enough. I've got this little diagonal here, and for 28, and this over like this, and this up like this. All right. There's the little dotted line diagonal. Okay. And the bottom is 8, and this is 10. And over here, the next one, this is 10, right? I copied it down right? And they want me to find this. So, what would I do? Question mark over 10, that 10 over there, would equal what? 10 over 8. You follow that? This over this would equal this over this. Or it could be the other way. You could say 10 over question mark equals 8 over 10. You just have to be consistent. So, let's call this x. 8x equals 100. X equals 12 and a half. Okay? Number 30. Okay. See, all these, now did you see you see what I'm going to show you here as we walk through this stuff is I'm kind of showing you the math tricks. And the trick here is just take as much of the picture as you need to do the work. Don't let it confuse you with all the other stuff. Now, the trick with this next one is to kind of unscramble the mess. So, number 29 through 32, here's how you unscramble the mess. We've got this triangle here with this little line. So I come over here and make this little line and have this triangle here. And this triangle and this big triangle are proportional. I mean, they're similar. You follow me? How do I know they're similar? Because they're angles. Their angles are all equal, okay? So now, look at problem 30. AP is 5. So that means right here, this is 5. PC is 4. This is 4. That makes this 4, doesn't it? Everybody follow what I'm doing? Labeling the parts. And BC is 6. This whole thing here is 6. Find BQ. They want me to find this section right here. So what do we say? 4 over all of this, that would be 9, wouldn't it? 4 over 9 would equal what are we going to do? 4 over 9 would equal oh yeah, this up here. Let's call this y would equal y over 6. Would that be right? 4 over this side would equal y over this side. You go, yeah, but we want to find this, and you're going to end up with this up with that top part. But what? But once I find this top part, what can I do? Subtract it from 6 to get the bottom part. Everybody see what's going on? So what do we have? 9y equals 24. Y equals 2 9s is 18 and 6 9s. Or 2 and what? 2/3. So this little section right here is 6 minus 2 and 2/3. See what's going on? You just fill in the numbers they give you and then use your proportion stuff to find an unknown. And if that's not what they want you to find, then go back and do the addition or subtraction to find it. Number 34. In problem 33, oh, I have to use problem 33 here. What's problem 33 say? I have a triangle, 6 9 12. 6 9 12. And 34 says if the length of the shortest side, oh, and the longest side of a similar triangle is 7. So I've got a similar triangle, same shape, same angles, just smaller, And what's the longest side of the similar triangle for 33? 7. So this is 7. Now your problem is, can you find this one and this one with the information you have? I mean, I know this is one of your homework assignments, but do you know what to do?
Yes. Just take.
Start with this, right?
Mhm.
And go 7 over 12 will equal,
X over
call this x, x over
6.
6. Everybody see what's going on? Okay, so that's how you work your part. Now, watch what they want me to do here for number 34. If the length of the shortest side of the smaller triangle is 5. So now they're telling me that for this triangle, the shortest side would be this side here, and it says that's 5. You follow what they did? They just changed the numbers. And now they want me to find the lengths of the other two sides. So I would go 5 over 6 equals A and B. 5 over 6 equals A over 9. Everybody see that? And 5 over 6 equals B over 12. So 6A equals 45. A equals 7.5. 6B equals 60. So B equals 10. Everybody see what's going on? Jackie has a piece of wire 18 inches long. Here's her piece of wire 18 inches long. And what does she want to do? She wants to bend it into a triangle similar to a triangle whose sides are 3, 4, and 5. 3, 4, and 5. So if we do, wait a minute, what's 3 plus 4 plus 5?
18.
That's 8. It is?
Uh-huh.
3 plus 4 plus 5?
It's 12.
12. Oh, that's not long enough. You follow me? The wire for this one, put this 5 in here, is only 12 inches long. And that wire's 18 inches long. So what am I going to do? Well, whatever I bend this up, when I put a little thing here and put a little thing here and bend this up to make a triangle, it's going to have to be 3 over x and y and z. 3 over x is going to have to equal what? 12 over 18. You see that?
Yeah.
Because the total, there's going to be the relationship. The ratio is going to be to that total. So then I just use that to find the information. So 12x is 54, is that right? So x would be 4 12s is 48. And 1/2. 4.5. So x is 4.5. And then I can just keep doing the other stuff to find the rest of them. Number 38, Betty wants to measure the height of a flagpole. She puts up a vertical post 8 feet tall and moves back in line with the flagpole and the post until her line of sight hits the top of the flagpole. That's a pretty smart idea. If you know the distances shown in the figure, what's the height of the flagpole? So what do we have here? We have this. Which way is it drawn? Draw it the same way to keep it straight for you. Here's this flagpole. And we come out here. And we come out here. And right here is that 8 feet? that what it shows? No, it's got 4 feet, doesn't it? It's got a thing here that says 4 feet. Then it's got another one over here that says 8 feet, doesn't it? I just finished the picture off to add the rest of it because this is the height of the flagpole and that's what I want to find. So what do we have here? Now, can you see where this stuff is going to be proportional? So let's see. Here's a triangle. That's 8. And here's a little triangle. That's 4. And do we know anything about the bottom of this thing? Yeah, it's 116 feet from here to here. From here to here is 116. And what is it from 4 to 8?
32.
So from here to here is 32. What do you think it is from here to here? I don't know.
32.
But if we call that x, this would be 32 plus x, right? Everybody follow what I have here in these pictures? So it looks like I can do a 4 over 8 equals x over 32 plus x. Everybody see where I'm getting my proportions? So what's this? 8x equals 4 times this. 4 times 32 is what? 128 plus 4x minus 4x minus 4x. 4x equals 128, so x is 32. So this is 32 as well. Now I've got the big triangle. That's what? 116 plus 32 is 6, 7, 8, 9, 10. 3, 6, 7, 8. Now I've got 180 here. And what do I have here? What does x equal? 32. So I've got 180 and 32 and 4 and h. You follow me? That I can set up the proportion. 32 over 180 would equal 4 over h. Then that would be 32h equals 720. H would equal, what is that? 264, 8. I can't do that in my head. You have your calculator there? Let's see what happens. 720 divided by 32 equals 22 and a half. No wonder I couldn't do it in my head. 22 and 1/2. So that's how tall it is. 22 and 1/2 feet. Is that fun stuff? You're not having as much fun as I am, but that's okay. We'll get there. Number 40. Gail wants to measure the distance across a small lake. See the figure below? So, what we have here, now do you see this? We have 2 triangles. Let's just take those triangles and break them out, put them on our piece of paper separately, and see if we can do this proportion stuff. Okay, what's the first triangle look like? Looks like this, with a little lake in here. And that's 240. And is that all we have? Looks like it. Then we have a little triangle out here that's similar. And what's the bottom of that triangle? 80. And how tall is it? 60. See where I'm getting my numbers? Do you see it? Do you see how I got this from that picture? Now, and do you see what happens? Is this in the way where you can't see things? Let me move this over a little bit. There. So, but do you see what happens when I pull the little triangle out and put it over there?
Mm-hmm.
Then it's easier for me to see the similarity. So this is what I want to find. So I go 60 over x equals 80 over 240. Could I also say x over 60 equals 240 over 80? Would that work too? Yeah, you'll get the same answer. See, 80x is 6 times that, 80x is 60 times that. So it's going to work out either way, just as long as you're being consistent with what you start with each time. Well, you can do the math, so we'll just keep going. Oh man, 42. We got a tunnel to build. And see, I look at that and I'm going, wow, they really messed those triangles up. How am I going to separate them? So I've got this triangle. Here's a tunnel. And then it goes down like this and out like this. Doesn't it? Yep. And it looks like this is 540. Where's my other triangle? It's right here at the end. Let's break it off here. But watch out, because look at the way this is labeled. This angle equals this angle, and this angle equals this angle. So do you see what I need to do? I need to rotate this thing around. So I've got this angle over here going up like this and over like this, and maybe a little higher, up like this. So I want to rotate this one around so that angle's over here. And then where does that put this other angle? If this angle's over here, that angle's down there, isn't it? That's not what I want, is it? Am I gonna have to flip this thing over to make a match?
Yes.
So rotating it's not gonna work. I'm gonna have to flip it. So here's when I flip it, this angle is here, and this angle is up there. Then I have to rotate that one. No, that's not getting it either, is it? This, and this, and this. When I rotate, okay, if I take this and flip it over here, then I've got this up here. That's 2. And where is, and this down here, which is 1. That's not getting it either. Then I have to flip it again.
If you just flip it over, or just not flip it up, just turn it over, it's gonna be the same. I think you're drawing it more on a diagonal than the book has it.
These angles are the same, and this one matches that one. So if I
Oh, I see what you mean.
see what's happening, if I flip this one, then this one's up there, but this one is still right here.
Maybe you could flip it upside down and then turn it backwards.
Flip it upside down and turn it backwards. So, or if I flip it this way, where here's this angle, and then, no, flip it this way. So, here, here, and here. Here's this angle, and then this one is where? Down here. And then, what, flip it again, where this one, no, where still got this one here, come on, still have this one here, and then when I flip it up, then this one becomes the 2, and now we've got this down here. Now, I got to figure out where my numbers go. So, where's the 18? It's what, right here? Is that the 18?
Mm-hmm.
And there's the 540. And do I have any other numbers? Oh, 20. Where's the 20? Out here? Is that the 20?
Yes.
So the 20 and the tunnel match, don't they?
Yes.
So there's the T. So now I can do my proportion. (540 over 18 equals T over 20). And you see when you're first looking at it, when it's all connected, it's kind of hard to see it, so you break it apart, rotate them, flip them, till you get them to the place where it makes sense. Number 44. Show that triangle ABD, that's this triangle here, ABD okay? Show that triangle ABD is congruent to triangle BCD. ABD and BCD. Is that right? BDC. And what is the other one? ABD. And what do we know about them? This angle and this angle are equal, and this angle, which one is it now? This one and this one. This angle and this angle are equal. So I need to do this rotating thing again. You see that? Rotate it around where these angles are matching up. So I'm going to turn it around where I've got D switch it around where this is D, that's 2, this is B, that's 1, and this is C. See what I'm doing to line them up so that they're the same way? Now I can put the numbers in. What numbers? They don't give me any numbers.
Just the thing.
Oh, page 525. How do you know triangles are congruent?
If they have two equal
Okay.
angles.
Does this side equal this side? Because it's the same thing, isn't it?
Mm-hmm.
BD and BD. And How do you know when triangles are congruent?
Their angles are congruent.
The angles have the same measure, or the angles have the corresponding angles have the same measure, and the side in between is the same length. So we've got angle, side angle, angle, side angle. All right. Well, let's move over here to page 532. What's number 48 say? ABCD is a parallelogram. Find the measure of BAD. Okay. We've got a parallelogram here for ABCD. Which way does it tilt? ABCD. Is that AB? ABCD. Okay. And then what did they do here? ABCD, where'd it go? A little diagonal going across here. And another one going across here. And what does it say? This is 70 degrees. And what else? This is 35 degrees. If this is 35, what's this? If these two lines are parallel, and this transversal goes across there,
It would be 35.
it's also 35. And if this is 70, what's this?
70.
It's also 70. You follow what's going on? So if this is 35 and this is 70, which angle do they want me to find?
BAD.
This angle here? Is that what they want? BAD? Oh, I have a triangle out here, don't I? That's 35 and 70 and something I don't know. But I do know that x plus 70 plus 35 equals 180. So x plus 105 equals 180. So x equals 75. How cool is that, huh? Number 50. Given the figure below, find the measure of angle C. If A is 75 and B is 30, what does C have to be? 180 minus 105? What's 180 minus 105?
$75.
So C is 75. And if C is 75, what kind of triangle is that? Isosceles. Number 52. Find the sum of the measures of the angles of a polygon with 20 sides. Can I draw a polygon with 20 sides? Probably not. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 19, 20. How many did I take off?
No idea.
Oh boy. You follow what's going on? I'm trying to make a polygon with 20 sides. And they want me to find the sum of the measures of all of these angles. Well, there's how many angles are there? There's 20 of them. There are 20 of these angles. 20 angles. So I just have to figure out what each one of them is. No, you don't. Did you know on page... What page is it?
There's a page ahead.
There's a formula somewhere. How come I don't have the page number?
528.
The sum
528.
Measures
Oh
of
yeah, I've got it out there.
angle
Page
of any
528.
convex polygon.
What's the formula say?
Is given by S equals n
The
minus
sum
2.
equals
N minus 2 times 180.
times 180. You know what n stands for?
No idea. Oh, that's the number of sides.
The number of sides, which is also
20.
the number of angles,
Angles, yeah.
right? So I put 20 in here, and minus 2 would be 18. What's 18 times 180?
Oh, wow.
18 times 180 is 3,240. So the sum of all the angles of this 20-sided polygon is 3,240. So that little angle right up there, I'm just curious, what would that be? If I divide by 20, because there's 20 angles, divide by 20, and I get 162 degrees for that angle. So now I can take my protractor and go around to 162 and make all my sides the same length and draw a picture of that on a piece of paper, so I wouldn't look as sloppy as the one I tried to draw up here. Is that cool stuff? Problems 53 to 58. Stop when you get to 57. Find the measure of one angle for each polygon. So, how many sides? Okay, how many angles or how many sides does a pentagon have? 5. So for number 53, put down 5. So that would be the number you use in the formula. You would go S equals n minus 2 times 180, and it would be 5 minus 2 times 180. You follow what's going on?
Mm-hmm.
So what about number 54? A hexagon. How many sides does a hexagon have?
6.
So it has 6 angles. So that would be S equals 6 minus 2 times 180. 4 times 180. Which would be 0, 4, 8, 720. That's the total. And if there was 6 of them, then that means each of them would be 120 degrees. Isn't that cool? That you can figure all this stuff out. Number 55, an octagon. How many sides does an octagon have?
8.
8. Number 56, a nonagon. How many sides does a nonagon have?
9.
9. How do you guys know all this stuff? You studied Latin somewhere in school? How many, number 57, a decagon.
No idea.
10.
10. And a 58, a dodecagon.
100?
No.
Do you remember last semester when we studied the duodecimal system?
Oh,
Duodecimal
no.
is base 12. So
No.
guess what a dodecagon is? It's a polygon with 12 sides or 12 angles.
I was afraid you were going to make us go back to the other decimal system.
No, we don't have to do that anymore. Well, there you go. So, if you have some questions, I'll be around here for the next hour or so to help you. Do you have another class after this one?
Yeah.
Oh boy.
That's
So I
not
can
till
help you for
9:30.
30 minutes. I got my little plastic out to do my rotation stuff with, and then I realized I have marks on it, so I can't really use it for that. Although I could have erased this stuff. Yeah, why didn't I think about doing that? Because you know when I was flipping that triangle, if I would have traced it and then put the labels on here and messed with it, we could have eventually got there much quicker. I got it out and then didn't use it. Too bad. So who has a question? From where?
Could you do 29?
On this exercise or the other one?
No, this one.
This one.
This one?
Yeah.
29? 8.2, number 29.
Because I don't think that the answer I got is the right one.
Okay, we got to draw our
I didn't
picture
even
again,
get
don't
to
we?
the answer part.
A,
I drew really horrible.
B, C. the big one. What is it? A, B, C. And then the little one, which is C and what?
Q.
And P and Q. And what? P and Q right here. Okay? So now, what are they telling us? For which one?
AP is 3. And
AP
PC
is 3.
Yeah.
This is 3.
Yep, and PC is 4.
And CQ is 4.
No, PC is 4.
BQ?
PC.
PC.
PQ is 4.
PC.
PC is 4.
I better just look at it, shouldn't I? PC is 4. PC is 4. All right.
BQ is 6.
And BQ is 6. All right. So now we got these two pictures out here. And what are we trying to find? They want you to find BC.
Yeah.
Find BC. Well, if this is 4, what's this? PC is 4 here.
Mm-hmm.
What's PC here?
It's 4.
4. Okay?
We're trying to find BC though.
Oh, okay. But now this whole thing is 7, right?
Yeah.
So now we have 7 over 4 equals x over, if this is x, that's also x, right? X over what? 6 plus x?
Are the sides equal?
What?
The sides aren't equal though, right?
But aren't these triangles similar?
Oh,
Mm-hmm.
yeah.
So 7 over 4 is proportional to, oh no, I did it wrong, sorry about that.
I was
7
thinking-
over 4 is 6 plus x over x, right? No wonder you were looking funny at me. Made a mistake.
Should be 7x equals
Now, do you see where that comes from? So now, can we work that? 7x equals 24 plus 4x minus 4x minus 4x. 3x is 24, so x is 8. If x is 8, then what's BC? 14.
Could you do 27?
Why not? 27. These triangles are similar. And what does it say about them?
Find the lengths marked X and
This one?
Y.
Is what? 5, 4, and what?
3.
5, 4, and 3. And what's the other one? Y, X, try to make it look like this anyway. Y, X, and 4. Agreed?
Yeah.
So this is 3, this is 4, this is 5, this is Y, this is 4, this is X. And these are similar.
Mm-hmm.
So that means I have similar triangles. The sides are proportional. So tell me what proportion I can put up here.
So do you do 5 over y?
5 over Y would equal
3 over 4.
3 over 4. Beautiful.
So my issue was I did that.
So then you've got 3Y equals 20. So Y equals 7 1/3. No, 6. 6 2/3.
Wait.
Because you divide 20 by 3, y1.
Because you divide by 3 on both sides to get
Yeah.
Y.
So, yeah. So y
So y is 6 2/3.
and
You see where I'm getting the 3y and the 20? Cross multiplying?
no, yeah. That's not my issue.
Okay.
I'm trying to find where I went wrong.
So y is 6 2/3. Now I need to find x. So what do I do for x? 4 over x would equal what? Four over x would equal 3 over 4.
Oh,
Again.
that's what I did. That's embarrassing.
Is that where you messed up?
No, I added 5 plus 4 instead of multiplying, even though in my head I was like, oh, multiply those, and then I did.
And then I added them. Yeah, that's right. That, I mean, see, and the thing is, if you talk out loud about what I did mentally, it helps you catch those mental mistakes. And then 3x is 16, so x is 5 1/3. So you want to do another one?
Mm-hmm.
Oh, what am I doing? I'm supposed to turn this off.